All right, guys, this is your lecture video for the PowerPoint slides today. We're going to finish up the 4 objectives that we need to finish up. So this is going to be objectives 4 through 7. Describe the concept of an automated fingerprint identification system, or AFIS. Describe visible, plastic, and latent fingerprints and the techniques for developing latent fingerprints. Describe the proper procedures for preserving a developed latent fingerprint, and then explain the scope of the FBI's next generation identification system, or NGI. And so we'll skip to slide 34 because we talked about the different patterns and primary classification system yesterday, and you should go back and watch the primary classification video that I just posted, and that will be for bonus if you do get that finished and completed. We'll add that to your test. All right, so the Integrated Automated Fingerprint Identification System, or AFIS, is maintained by the FBI, and it is the primary fingerprint database. It is located in, or the original fingerprint database, when it was just kept on cards, was in Leavenworth, and we talked about that with Will West and William West. There's nearly 750 million fingerprint images on this database. We talked about how there's the DNA databases and the shoe print databases and paint databases. Well, this is fingerprints. In 2014, the AFIS was integrated into the Next Generation Identification, or NGI, system. We'll talk more about that at the end of these PowerPoint slides. Each state has its own AFIS. It's run by the states, and then we've got the local departments that can access that, and then federal, of course, which is the FBI. It's maintained by the FBI. So the heart of AFIS technology is the ability of the computer to scan and digitally encode fingerprints so that they can be subject to high-speed computer processing. This is fast, but it can still take a long time for it to make a match, just because the computer narrows it down to a group of people. It actually can narrow it down to about 10 people or so, and then you still have to have a human expert to go through and match those. It's not enough for the computer to do it. And then, like we discussed yesterday, you don't want just one human taking a look at it. You want 2 at least, so you've got the computer and then 2 humans finalizing a conclusion on making a positive match or identification on these fingerprints. And so, we watch these TV shows, and of course they try to solve these crimes in about 40 minutes to an hour, but it doesn't really take that long. It takes a lot longer sometimes, even with high-speed computers. So AFIS aids in classifying and retrieving fingerprints. So it's going to convert this image of a fingerprint into a digital minutia so that we can see those. It contains data showing the ridges at their points of termination, which we call ridge endings, and then their branchings into 2 ridges, which we call bifurcations. When the search is complete, a computer can make thousands of comparisons per second. The computer produces a list of similar fingerprints, and then, again, like we've already said, an expert is going to examine those lists of fingerprints to narrow it down to make a positive match, and then that expert is going to be backed up by another human expert. Once a fingerprint touches a surface, body perspiration, we talked about this yesterday, and or oil present on the finger ridges are transferred to the surface, and that's what leaves the impression or latent invisible print. Again, all the TV shows get this wrong because they call all fingerprints latent prints, but a latent print truly is an invisible print. Then we have what we call visible prints, and these are made when fingerprints touch a surface after the ridges have been in contact with something that has color to it, such as blood, paint, grease, ink. And so this allows us to be able to see those prints. So this might be like if you touch the lead of your pencil and then you touch it to paper, now we can see those prints. Or if you get ink on your fingers from a pen and you touch the surface of the desk, now we can see those prints. Plastic prints are a type of visible print. These ridge impressions are left on a soft material like putty, wax, soap, or even dust. Locating visible or plastic prints at a crime scene normally presents little problem to an investigator because the prints are usually distinct and visible. Latent prints deposited on hard and non-absorbent surfaces like glass, mirror, tile, painted wood. These are preferably developed using the powders, and we're going to practice this next week when we get back to school. We're going to have different a specific type of powder. We usually like to use a dark powder with a light, maybe cornstarch in it. I like to use lamp black with cornstarch. It gives it a good contrast. And you can dust for the prints and then lift them with tape. Prints on porous surfaces like papers, cardboard, and cloth generally require treatment with chemical. This could be iodine fuming, ninhydrin, superglue fuming. Superglue has cyanoacrylate in it. You're going to need to know that for the test. It's probably going to be on here coming up, but cyanoacrylate. Cyano means blue. But we're going to do superglue fuming in the lab after we do our fingerprint dusting. And you need to do the dusting first and the superglue fuming after, because once you do the superglue fuming, you need to dust for the print and lift the print. So you need to know how to do the dusting first. A device called Reflected Ultraviolet Imaging System, or RUVIS, can aid in the detection of these latent fingerprints or invisible without any chemicals or powder. Once located, the crime scene investigator can develop the print in the most appropriate fashion. Of course, before we try to do anything with the prints, preserving them or lifting them in any kind of way, obviously we want to take pictures because, as we've talked about before, with preserving any kind of evidence, it can be destroyed. So the best thing to do is take a picture first. Powders available in a variety of colors can be applied with a brush or a magnetic wand, and they adhere to the perspiration or body oils of the print. Again, there's different colors, different types, but I like to use the dark powder mixed with a lighter color. It kind of gives it a gray or a dark gray contrast, and it allows us to be able to see the print really well with what we work with, especially like on our really dark black lab tables, if we're dealing with that. So iodine fuming involves heating iodine chemicals, which creates vapors that combine with the latent print, and it allows it to become visible. Iodine prints are not permanent. They will fade, making it necessary to photograph the print immediately. So once you've used the iodine fuming, it becomes visible. You take that picture, and then you can try to do something to preserve it. And this is an image of a heated fuming cabinet in order to make that print visible using iodine fuming. And I have done iodine fuming in the lab before, but I prefer superglue fuming. Ninhydrin is a chemical that reacts with trace elements of amino acids. Remember, amino acids are building blocks of proteins, so we're targeting those smaller units of the proteins present in latent prints to produce a purple or blue color. Physical developer is a silver nitrate based reagent used to develop prints when other chemical methods are ineffective. We use silver nitrate when we did our alcohol lab, breathalyzer lab. Iodine fuming, ninhydrin, and physical developer are used on porous surfaces. Remember, porous surfaces are those types of surfaces that can absorb moisture in some way, form some type of format, so like papers, cardboards, things like that. Whereas superglue fuming would be more for hard surfaces like metals, plastics, things like that. Superglue is approximately 98 to 99% cyanoacrylate or cyanoacrylate ester. It means it's like an alcohol type thing. It will evaporate real easily in air. This is a chemical that interacts with and visualizes a latent print. Superglue fuming can be accomplished by using either a fuming chamber for up to 6 hours or a handheld wand that heats a small cartridge containing cyanoacrylate. Now, here's the thing. This can be done really quickly in our classroom lab with the aquariums that I've got in the back. If you use a hot plate and water, I've got these little small chemistry lab shot glasses. They look like shot glasses, but you put the shot glass on the hot plate, put a little bit of water in it. You put the other shot glass in there and put just a little bit of super glue in there. You put whatever's going to be in there that you're trying to get the fingerprint off of, and you completely seal the chamber off. No air can get in, no air can get out. And it does it within like 5 to 10 minutes. You got fingerprints. So it can happen really quickly. It doesn't have to be 6 hours. But superglue fuming works on non-porous surfaces. It will not work on paper, will not work on cardboard, nothing like that. It won't work on skin. If you were in a lab and you were trying to get fingerprints off of skin, superglue fuming is not going to work on that. It's going to work on plastic, metal, so on. Fingerprints can also be illuminated by shining a laser into the print that causes the perspiration or oils to fluoresce or glow. Fluorescence of fingerprints can be very sensitive. Fingerprints are treated with chemicals that would induce fluorescence when exposed to lasers or highly sensitive light sources. You can use alternate types of light sources like quartz, halogen, xenon arc. Once the latent print has been visualized, then you can permanently preserve it. Again, take a picture first. And this is done so that it can be used as court evidence. The photograph must be taken before any further attempts at preserving are made, again, because it can be destroyed in the preservation process. If the object is small enough to be transported without destroying the print, it should be preserved in its entirety. Prints on large immovable objects that have been developed with a powder can best be preserved by lifting it with a broad adhesive tape, and again, we're going to practice this next week. Then the tape is placed on a properly labeled card, transferred with a good background contrast. If you're using a dark black or gray powder, then you want a white card contrast. And here's a picture of showing those prints being lifted off of a metal aluminum can. So digital imaging is the process by which you convert that print into a image onto a computer, and then it can be preserved basically forever, as long as that computer lasts and that digital platform lasts. An important and useful tool, especially for fingerprinting identification, is the compare function that allows you to put two prints side by side, an unknown and a suspect print, for example, and be able to match those up simultaneously. Okay. Then we have the next generation identification system from the FBI. It contains a wide range of resources for law enforcement, including the RAPBAC service, which notifies agencies of criminal activity of individuals already in the system. So if their print pops up and they've already been in the system, then it alerts authorities. The Interstate Photo System is a database of mugshot photos with 10 prints. And then, as we've already talked about earlier, facial analysis, comparison, and evaluation, or FACE services provide facial recognition capabilities with a database of driver's licenses, the photos on them, and then visa application photos as well. The 10-print system contains fingerprint images, and then a latent print search algorithm is used to yield better search results for comparison. There's also a palm print system that can match up palm prints, repository of individuals of special concern or risk, allows them to search for people that are threats, fingerprint scans with a cell phone size scanner, and that is it. As usual, if you have any questions, make sure you send me an email or a message on Google Classroom, and I will answer those questions. Make sure you're working on your review questions. That is your assignment for today. And that is it.